In this video, we're going to examine Ethernet frames using Wireshark. So just as a review, the Ethernet 2 frame is made up of these sections: the preamble, 8 bytes, the destination MAC address, 6 bytes, the source MAC address, 6 bytes, the frame type, the data, and the frame check sequence, which is 4 bytes. When we start looking at this stuff in Wireshark, we're going to see that the preamble and the frame check sequence, those are not going to be included in Wireshark because that just makes sure, it identifies that it's an Ethernet 2 frame, and this says the frame contents are correct, because if they fail this frame check, we're just going to discard it. So the first thing we want to do is we want to find out what information we're working with here in terms of our local PC that we're going to be looking for in Wireshark. So we want to do the ipconfig/all so we can see everything. You can see there's a lot of information here that comes out in mine. The big thing we want to focus on here, and this one is Ethernet adapter, Ethernet 4 for our example. Yours may be 1, it may be 7, it could be a whole bunch of different things. We're not going to be looking at Bluetooth network connection. We're not going to be looking at virtual Ethernet adapters. These are for the virtual machines I run. These are, of course, Bluetooth devices. Chances are you're either going to be looking for an Ethernet adapter if you're hardwired, and if you're using wireless, you're going to look for a wireless adapter. And the way you're going to be able to identify it is you're going to be able to see, in this case, like my IP address is 10.0.0.100 for this computer. Which, if we do it this way, you can kind of see the default gateway a lot clearer because it doesn't include all the extra stuff. So again, here's our IP address, our subnet mask, and then here's our default gateway. After you've installed Wireshark and you launch it, this is the screen you're going to be presented with. Chances are you're not going to have these. These are previous files that I've looked at. But you're going to see down here under Capture, you're going to see a list of interfaces. If you get a yellow warning here, says no interfaces detected, there's two things to try. First thing is try to run Wireshark as a network as administrator from the launch menu, because sometimes it needs those extra permission levels to be able to get access to the interfaces so it can actually pull all the packets and all the information that's coming across. Another one, like I had to do with mine, was the WinPCAP that Wireshark installs by default does not work for Windows 11, so I had to install the NCAP instead. And I'll include links at the bottom of this video if you need to install WinPCAP or NCAP. So what we wanted to do is, if you remember back our previous look here, we saw that Ethernet adapter Ethernet 4 is what we're going to be capturing on, because that's our active internet connection. So if we come down here, we select Ethernet 4, we double click this, and you can see it's going to start capturing data. This is capturing every piece of information that's flowing across my Ethernet connection right now. And it's not necessarily just stuff for me, it's anything that's on that wire. So it could be any broadcast information, there could be a whole bunch of different things going on. And you can see here, there is a lot of information going across this network right now. So the first thing we want to do is we're going to try to filter this. So let's look for ARP requests or ICMP. So we're looking for ARPs or we're looking for pings. And you can see here we've already filtered this down. So right now we're just seeing ARP request. And you can see here the source address and then the destination where it's going. In these cases, these are broadcast. Let's go ahead and just stop this so it's not capturing live data right now. So we see here, let's go to this Samsung broadcast address here. So when we click on this, we can see it's from a Samsung. And then if you look here, this shows you all the actual bits that are in that Ethernet frame. If you want to see them, how things break apart, you can go through all this and it's going to highlight all the different spots for you. But what we're concerned with is the Ethernet 2 frame right here, Ethernet 2. And you can see our destination MAC address is FF, which is known as the broadcast address. It's coming from a Samsung device, in this case, probably one of the cell phones in our house. And you can see the MAC address is 4016 3B F0 4266. So here's our source MAC address, here's our destination MAC address. And as you remember back in this picture, you can see destination address is first, source address is next. So if we come back here, here's our destination address, and then right here, this is our source address. So you can see first destination, and then here's the source. So it's just like the frame breakdown. The next thing you're going to see is the type Ethernet 2. If we go back here and we look, we see frame type. And you can see that right here, 0806. And if you can see here, that identifies it as an ARP packet. The last thing here is the data, in which in this case is going to be the ARP request. So that's all this remaining stuff is all the data. But if you click this, you can see here's the address resolution protocol request. And we can expand that and we can see all the stuff that's in that data. So we can see it's an IPv4 request. Here's the sending MAC address, F04266. You know, here's the full thing. But these are the, if you remember, these were identify it as Samsung, the first 3 hextets, and then the final 3 hextets are like the serial number. So again, in this case, Samsung F04266. We see it's coming from the IP address of 10.0.0.157, and it's trying to find out who is 10.0.0.1. We know by default that's going to be the router, but we don't know what the MAC address is, so it's sending that request out to the broadcast. So that's the example here, but because this device, this computer, is not a Samsung device, so we're not going to be able to see the response because the response is not intended for this computer. So what we're going to have to do is we're going to have to generate one of those. So what we're going to do is we're going to start a new capture. We're going to go ahead and wipe all the stuff out, so I'll continue without saving. And then we're going to come back over here to our this, and let's say ping, let's go 10.0.0.1. So we're going to ping the default gateway. You can see we're getting the replies here. Okay, so that's done. So let's go ahead and stop this. And unfortunately, we're not going to see the ARP request because we've already done that with this computer. So let's see if we can generate a new ARP request that we can actually see. So let's come back over to our command prompt, and we're going to ping 10.0.0.50. So this is a server on my network, one that we haven't actually been in contact with. So let's go ahead and stop this. And then so what we're going to see here is we're going to look for, oh, here we go, Gigabyte, which is my motherboard here. It's going to say, you know, here's our Ethernet 2 frame, broadcast out to, you know, from here of EFBDE7. We look at the ARP request, and it says, I am 10.0.0.100. I am looking for 10.0.0.50. Please tell me the MAC address where I need to send this. And then we get a response back here. You can see here's the destination. It's going back to my gigabit, the EFBDE7. It's coming from 41A5D6. Now if we look at the address resolution, we can see here, oh, this is a VMware, so it's a virtual server. It says here, this is my MAC or my IP address. Here's my MAC address. So then when we want to ping it, you can see here these ones highlighted in pink are the ping request. So right here, we're sending a ping out, 10.0.0.100, we're pinging to 10.0.0.50. So if we look here again at this destination, we now know the MAC address where we're sending this, 41A5D6, and we're sourcing it from the Gigabyte. And then you can see the same thing where the response comes back. It's going to the Gigabyte, coming from that VM device. So the other thing we can do is we can also filter this again. So we can do ICMP, and we're going to just see the ICMP request. You can do the same thing with like HTTP. Oops. You can see any HTTP request. So like right now, let's go ahead and we'll start a new live capture HTTP request. You can see here we're going to load up the community college webpage. And if we look here, you can see that same thing. The big difference between you're going to get into when we get into IP information in the next couple chapters is we're going to an IP address here that's not on our network. So if we look here and we see Gigabyte, you know, here's where it's coming from, which we already looked at, EFBDE7. But the destination here is a Belkin device. And the Belkin device is actually my a Linksys router, because Belkin now owns Linksys. So the next hop is going to be that router. So the MAC address that we're going to send stuff to on layer 2 is the next hop, which is my local router. From there, that will look up who's got the 155.42.51.1115. If it's not directly connected, they're going to find the MAC address for the next router, and then they're going to send it over to that next router to try to get to where it eventually reaches CCV. Wireshark is a very powerful tool because what you're doing is what's called a packet capture, or PCAP, and you're looking at every single piece of information that's going across the medium that you're focused on. In my case, that is a actual Ethernet, a gigabit Ethernet connection. It could be a Wi-Fi connection. It could be a whole bunch of different things. The big difference that you're going to see is when it comes to Ethernet connections is because I'm connected to a switch, everything is segregated. So only stuff that's coming down that physical wire to my NIC is going to show up in this. If you're doing a capture on Wi-Fi, and say like at CCV, if you're running a Wireshark on the Wi-Fi there, you're going to see the packets from every single person's, like all their cell phones that are wirelessly connected to the router there at school. This is why we say you should not transmit anything in plain text, because if we transmit something in plain text, you're going to be able to log in and actually see that in one of these packet captures. Wireshark is a very powerful tool. One of the best things that you can actually do with it is once you've captured all the stuff is you can go to File, and then you can do Save As, and then we can just save it here in the documents. We're going to call it Test PCAP. And then you can send that file to somebody else with Wireshark or another PCAP program, and they can open it and actually go through and look at all this stuff. It's very useful for troubleshooting. For example, at work when we're having a problem with a voice over IP phone that's not able to connect, we can take a Wireshark capture and figure out what's going on. Are the packets actually leaving the network? Are they coming back from the phone switch to the phone? And we can try to narrow down, exactly what's happening where. It's a very powerful tool. It can be a little bit of a struggle the first time getting it going because of the NCAP and the WinPCAP stuff. Hopefully you don't run into any problems, but if you do run into any issues with it, feel free to go ahead and post in the forums or reach out to the instructor, and they should be able to help you with this. Thanks, and look forward to using this some more.